Hey y'all, today is January 18th and we are going to review lesson 5.2, solve two-step equations with a little mini lesson. So grab a piece of paper, a pencil, and your calculator, and let's get started. So number one right here, it says solve the equation. Identify what steps were used to solve the equation. So we're solving this equation right here. And remember, we're always doing inverse operations to undo things and work our way from the outside into the center close towards our variable. So the first thing I always do is I always draw a line down my equal sign. That helps me see that whatever I do on one side, I must do on the other. And our goal here is to get this x by itself. And remember, we're working our way from the outside in. So I need to undo subtracting 2/3. Well, I undo that by adding 2/3. So I'm adding 2/3 on both sides. And by doing it on both sides, it keeps everything balanced. So on the side with the x, the 2/3 cancel out, and 12x is all that's left. So I just bring that down. Okay, now on the other side, so I've got 83 and 1/3 plus 2/3. And the good news is that 1/3 plus 2/3 makes 3/3, which is 1 whole. So I have 83 plus 1, which is 84. So 12x equals 84. Now I'm still trying to get that x by itself, and it's connected to 12 through multiplication. So I undo that by dividing 12 on both sides. So on the side with the x, the 12s cancel out, x is by itself, and then 84 divided by 12, if I put that in my calculator, I get 7. So x equals 7 is our answer. Okay, now it did ask us to identify what steps we took, and we talked about them, but the first step that we took is we added 2/3. So first, add 2/3 on both sides. And then the second step we took is we divided by 12. So then divide by 12. And that's how we were able to isolate our variable. Okay, number two, solve the equation. 3x plus 2 equals 17. First things first, draw a line down my equal sign. I'm trying to get this x by itself, but I have to work my way from the outside in. So I'm first going to undo plus 2. Well, I undo that by subtracting 2. And I do that on both sides to keep things balanced. On the side with the x, 2 cancels out. 3x is by itself. 17 minus 2 is 15. So 3x equals 15. Now to get that x by itself, it's connected to 3 through multiplication, so I undo that by dividing. So I'm dividing by 3 on both sides. 3's cancel out. X is by itself. 15 divided by 3 is 5. So x equals 5 is our solution. And I can always plug that back in to check my work. Let's move on, though, to number 3. So solve for p. 0.6p plus 4.5 equals 22.5. So I'm going to zoom in. First things first, draw my line. And I'm trying to get that p by itself. So I have to undo things from the outside in. So I'm first going to undo this positive 4.5 or plus 4.5. Well, I undo that by subtracting 4.5, and I subtract on both sides. Okay, so on the side with the p, the 4.5 cancels out, and I just bring down 0.6p, and I set that equal to the other side, which is 22.5 minus 4.5. And if I put that into my calculator, I get 18. So 0.6p equals 18. Now I'm still trying to get that p by itself, and it's connected to 0.6 through multiplication. So I undo that by dividing by 0.6 on both sides. So 0.6 cancels out. P is by itself. And if I put 18 divided by 0.6 into my calculator, I get 30. So P equals 30 is my answer. Okay, moving on to number 4. Henry hit three more home three more than half as many home runs as Jack hit last season. Henry hit a total of 8 home runs. Okay, so there's some important information here. He hit 3 more than half as many home runs as Jack hit last season. Henry hit a total of 8 home runs. So in part A, we're asked to write an equation that we could use to find the number of home runs, X, that Jack hit last season. So I'm going to go ahead and define my variable. It does it for me, but I'm just going to write it. X represents the number of home runs Jack hit. Okay, now 3, half, and 8. How can I represent half as many home runs as Jack hit? Well, wouldn't that be 1/2 X? Half as many home runs as Jack hit? Yeah, I like that, okay? Now 3 more than that. Well, more than means I'm gonna add 3, and I want to set that equal to my total, but he hit a total of 8 home runs, so 8. So 1/2 X plus 3 equals 8. That is our equation that represents this situation. Now, hopefully you look at that and say, ooh, that's an equation I know how to solve. Because in part B, it says how many home runs did Jack hit last season? That means we have to solve that equation. So I'm just gonna rewrite this over here where I have a little bit more room. So we have 1/2 X plus 3 equals 8, and we're going to solve this equation. So first thing, draw my line down my equal sign. Now I'm trying to get that X by itself, and I have to work my way from the outside in. So I need to undo plus 3 first. So how do I undo that? Well, I subtract 3, and I do that on both sides. My 3's cancel out, so I'm left with 1/2 X equals 8 minus 3, which is 5. Okay, now my next step, I know that I'm trying to get that X by itself, and it's connected to 1/2 through multiplication. Now I could divide by 1/2, but when we have a fraction connected to a variable through multiplication, the easiest way for me to undo that is to multiply by the reciprocal, which is 2/1. But is there another way that I can write 2/1? 2. So I'm really just multiplying by 2 on both sides. Okay, so on the side with the X, what happens is this cancels out and X is by itself. Now on the other side, 5 times 2 is 10. So 10 home runs is the number of home runs that Jack hit last season. Okay, moving on to number 5. Sarah saved $12.75 every week for a number of weeks. She received an additional $25 during the last week in which she saved money. Write and solve an equation to find the number of weeks for which Sarah saved money if she has $114.25 now. Okay, so some important information here. She saved $12.75 every week. She received an additional $25 during the last week, and now she has $114.25. Okay, well, it does tell us what our variable represents, number of weeks, W. I'm just going to write that over here. So W equals the number of weeks. Okay, so which of these numbers has to be attached to my variable W? If you said 1275, you're right, and there's a key word. That key word is every. Remember, when you see each, every, per, that often means that that number is going to be attached to our variable. So we've got 1275. Let me write that a little bit better. W. And then she also had $25. And now her total is $114.75. Nope, 25. $114.25. But now I've got to figure out what operation connects these two numbers right here. Well, that $25 went into her total savings. So we're going to add it with what she was saving every week. Now this is an equation you know how to solve. To solve this equation, the first thing I'm going to do is draw my line down my equal sign. You know I always do that first. Now I'm going to identify my variable W, and I'm working my way from the outside in. So the first thing I have to undo is this plus 25. So I'm going to subtract 25 on both sides. So 25 cancels out. I've got 12.75 W equals, and when you say 114.25 minus 25, you get 89.25. So now to get that W by itself, it's connected to 12.75 through multiplication, so we undo that by dividing. So we're dividing by 12.75 on both sides. So on the side with the W, the 12.75 cancels out, and W is by itself. And on the other side, I have 89.25 divided by 12.75. And when you put that into your calculator, you get 7. 7 what? 7 weeks. That is our answer. Okay. Moving on to number 6. In 1 month, Jason earns $32.50, less than twice the amount Kevin earns. Jason earns $212.50. How much does Kevin earn? Okay, so you have one just like this on your homework. So some important information. $32.50 less than. That means I'm going to subtract $32.50 from something. Okay, twice the amount that Kevin earns. And then I know that the total that Jason earns is $212.50. Okay, so we've established that we're subtracting $32.50. Well, we're subtracting it from what? And really a key is twice the amount. That means 2 times whatever Kevin earns. So I don't know what Kevin earns, but that's going to be what my variable represents. So let's use K. And let's say K represents Kevin's earnings. So twice of that is 2K. So we have 2K minus $32.50, and that's going to equal Jason's total, which is $212.50. Okay, now this is an equation you know how to solve. The first thing we're going to do is draw our line down our equal sign, and we're trying to get this variable here by itself. And I have to undo things from the outside in. So the first thing I'm going to undo is subtracting $32.50. So I'm going to add $32.50 to both sides. Okay, so when I do that, my $32.50 cancels out. I bring my 2K down. So 2K equals. Now over here on the right-hand side, I'm going to add $212.50 plus $32.50. And when I put that into my calculator, I get $245. Now I'm still trying to get that K by itself, and it's connected to 2 through multiplication. So I undo that by dividing. So I'm dividing by 2 on both sides. So on the side with the K, the 2's cancel out. So K is by itself. And then on the other side, 245 divided by 2, when I put that into my calculator, I get $122.50. And I went ahead and wrote my dollar sign because remember we were talking about money, so that's important that I have that. So Kevin earns $122.50. Okay, last one, number 7. What steps do you need to take to solve the equation? So our equation is right here, 1/2 x plus 6 equals 18. And we have some multiple choice options. So remember, if I'm looking at this equation, the first thing I do is draw my line. And I'm trying to get this x right here by itself. So I want to work my way from the outside in. So the first thing I need to undo is that plus 6. Well, I undo that by subtracting 6. So let's see if subtract 6 is an option. Okay, so I have two options that say that. So I know it's not going to be A or C. It's either going to be B or D. Okay, so we're subtracting 6. That leaves us with 1/2 x equals 18 minus 6 is 12. So now I know that to get that x by itself, it's connected to 1/2 through multiplication. And normally I would say, okay, I'm going to divide by 1/2. But when I have a fraction attached to my variable through multiplication, the best way for me to undo that is to multiply by the reciprocal, which is the fraction flipped upside down, so 2/1. But 2/1 is the same thing as just 2. So I'm multiplying by 2 on both sides. Is that an option? Not for B, but it is for D. So that means that D is my correct answer. And since we're almost done solving that equation, let's go ahead and do it. We know that this all cancels out, so x is by itself. 12 times 2 is 24. So the answer to that equation, or the solution to that equation, is 24. So that is the end of our little mini lesson on 5-2. Have a great day.